Hi folks, we're taking a look at 6b on page 575. So what they're asking us to do is to determine when the derivative of this function is equal to 0. Okay, so first thing we'll do is take the derivative. Okay, so f prime at x here. Well, we're going to have to use a chain rule, so the outside function is, again, if you still want to think of this as being your placeholder variable u, so the derivative of u to the 1/3 is 1/3 times u, which is ln x plus 2x to the negative 2/3. Okay, and then I have to multiply that by the inside function, so u with respect to x. Okay, so derivative ln x is just 1 over x, plus the derivative of 2x is just 2. Okay, now if I were just asking you to find the derivative, I'd likely ask you to leave it in simplified form, but I actually have to solve an equation here. Okay, so because I want to determine when the derivative is equal to 0. So first thing I notice is that the 3 is already in the denominator, and this whole expression is going to go into the denominator, so this is going to be some sort of rational type expression. Okay, so and here I'd like to have this as one single fraction. Okay, so I know all this is going to go into the denominator, so I'll deal with that later. So let me add these two. So here, common factor is just x, so this just becomes 1 plus 2x over x, and all this is going to go into the denominator, so 3 times ln x plus 2x to the negative 2, just to the 2/3, okay, because I'm bringing it down to the denominator. Okay, and now here this x can be brought down into the denominator also, so I'm just left with 1 plus 2x over 3x times ln x plus 2x, all to the 2/3. Okay, now why did I put it in this form? Okay, because when I'm solving a rational equation, I'd like to have it as a single rational expression, okay, and factored if at all possible. Okay, so here I've got that because there's just one term in the numerator. This is already factored. But since I only want to know when this expression is equal to 0, I'm only interested in the numerator, okay, because that's what makes a fraction 0, is when the numerator is equal to 0. So in the end, I'm just solving this simple linear equation, so I get x is equal to negative 1/2. Okay, and of course it's very tempting to just stop there, okay, until we remember that, hey, we've got logarithmic expressions inside in the original function. Okay, so anytime you have things like square roots or fourth roots or logarithmic expressions, you better make sure that your answer is actually valid for the original function. And when we look here, we see ln x, and we cannot take ln of negative 1/2. Okay, so this solution is invalid, so in the end, we have no solution, okay, since ln of negative 1/2 does not exist. Okay, so just to recap, number one, find the derivative using the chain rule. In this case here, we did need to simplify because we had to solve the equation for the derivative being equal to 0. And once I find my answer, make sure that you check the original function because it had logarithmic expressions, and you also would want to do that if there's any kind of square roots, fourth roots, or things like that. Okay, that's it for this one.